Hi everyone. Today we will present about the hydroelectric power plant. And in this presentation, we will introduce the hydroelectric and explain to you guys how the hydropower plant works and some real examples used around the world. We hope this presentation will make you understand about the hydropower. And before we begin, let me introduce myself and my team members. So I am Joshua Tan Hwang Wei, and my number matrix is B13231039A.
Good morning, everyone. My name is Makai Siang. Number metric B132410363.
Hello sir, my name is Yong Chi Yi. My matrix number is B13241031.
Alright, let's start our presentation today. So, what is hydropower? Basically, it's electricity generated from moving water. When water flows or falls through the turbines will spin, and that spinning motion drives the generator to produce the electricity. And it is considered clean and renewable because it does not release carbon dioxide during operation. So, the first hydroelectric power plant was built in 1882. It was called the Vulcan Street Plant and is located in Wisconsin, USA. It did not generate a lot of electricity, but it was very important because it proved that we could use water to reliably produce power. And today, hydropower is still one of the biggest source of renewable electricity in the world. And it is reliable, stable, and can just adjust power quickly when demand goes up. Of course, building dams can affect river like ecosystems, but overall, hydropower remains a key renewable energy source because it is clean, renewable, and efficient. So you guys can looking for the picture one. It is the Walken Street plant, and it is also the first hydropower plant in the world. And then the second picture is the location of Walken Street plant in Wisconsin, USA. So after learning about hydropower plants, now I will show you the hydropower compared to other power generation. For the first one, hydropower, and it is renewable and low emission, and it is reliable, can adjust output very quickly. But the advantage is it high construction costs, and it may impact the ecosystem, and it also needs suitable geography. Then you can build it. For the coal, it is very low cost and widely available, but it is high pollution and it will also release the carbon dioxide and no renewable energy. And for the natural gas, yeah, it is cleaner than coal, renewable also, but it still emits carbon dioxide, and the fuel cost is unstable. Maybe sometimes it's cheap, sometimes expensive lah. Yeah. And for the nuclear, very low emissions, renewable and high output. But the disadvantage is also high construction costs, safety concerns, and long planning time. For the solar, it is renewable, clean, low operating cost, but the weather dependence is the most problem. Yeah, and in the return, it also needs large area and storage. For the wind, it also renewable energy and very clean and low operating cost, but it also weather dependence, intermittent, visual or noise impact.
Now, I will present about basic operation and its principle. Water storage, which is potential energy. Water stored at a height in a dam. Higher elevation is equal to higher potential energy. Second, water flow through penstock. When the plant operates, gates open and water flows through a large pipe called the penstock. So, potential energy convert to kinetic energy due to gravity. Third, turbine rotation, which is mechanical energy. Fast-moving water strikes the turbine blades, making the turbine spin. Then, electricity generation in generator. The rotating turbine shaft is connected to a hydro generator. So, the generator converts mechanical rotation into electrical energy. And last is transmission. The electrical output is stepped up by a transformer and sent to the grid. Next is function of major components in a hydropower plant. First is dam. It stores water and creates a height difference, which is head to regulate water flow. Second is reservoir. It acts as energy storage to ensure continuous supply. Third, penstock. It directs high pressure water to the turbine and it's designed to minimize friction losses. Fourth is turbine. It converts the water's kinetic energy into mechanical rotation energy. The types of the turbine is Pelton, which is high head, Francis, which is medium head, and the last type is Kaplan, which is low head. The next component is governor. It controls the turbine speed by adjusting water flow. It maintains constant generator speed and frequency, like example 50 or 60 Hz. The next component is hydro generator. It converts mechanical energy from the turbine into electricity, while the electricity output is in AC power. Next is transformer. It steps up voltage for efficient transmission to the grid. The last component is tail race. It returns water back to the river or downstream.
Next, I will explain the construction process involved in a hydroelectric power plant. The first, the first stage is site preparation. This involves clearing the land around the river to make space for the dam structure. Soil testing and geological surveys are also carried out to ensure the ground is stable and suitable for heavy construction. Next stage is installing the penstock, which is the large steel pipe that carries water down to the turbines. The pipes are installed section by section. After fixing each section, all joints are welded tightly and cut to prevent corrosion and leakage. Lastly, the powerhouse is built. A deep concrete foundation is constructed near the river to support the heavy turbine and generator equipment. Then, reinforced concrete walls are erected to create a strong structure that can withstand water pressure and pressure. Actual site. Here is an example of an actual hydroelectric site, Bakun Hydroelectric Dam in Sarawak. This dam is located in Belaga District, Sarawak, Malaysia. It is a concrete faced rockfill dam, which means the core is made of rockfill with a concrete face to prevent water leakage. Bakun Dam stands at 205 meters, making it one of the tallest dams in the world. Construction was complete in 2011, and the operator of this dam is Sarawak Energy Berhad, or SEB. Another example is the Murum Hydroelectric Dam, also located in Sarawak. This dam is built on the Murum River and uses a roller compact concrete design, which allows faster and more efficient construction. The dam stands at 141 meters tall and was complete in 2014. It is also operated by Sarawak Energy Berhad. This dam is located in Tenom, Sabah, Malaysia, and it is classified as a mini hydro power station. Although it is smaller compared to large dams, it still plays an important role in supplying renewable energy to the local area. The dam has a height of 74 meters and was complete in the year 2009. Since then, it has been operated by Sabah Electricity Sdn Berhad, also known as SESB.
Overall, hydropower is a dependable renewable energy source that contributes greatly to the world's electricity supply. Although it faces certain environmental and financial challenges, it still stands as an important option for clean and sustainable energy. And this is our reference. So if you want, please review them on your own. Okay, so that's all from our group. Thank you for lending us your ear. Bye bye.